So intermolecular forces give rise to several different properties or phenomena. Surface tension and viscosity are two of these things. So surface tension. Here's a picture of some water in, looks like a petri dish, and a paper clip floating on top of the water. Does metal usually float on water? No, not unless it's like in the shape of a boat or something, right? This paper clip should sink, but it's not sinking. If you look closely, you can see that there's some distortion here. It's almost like there was a skin on top of the water, like a layer of plastic or something, and it was sitting on top of that, and it's kind of pushing down, but it's not going all the way through. This paper clip is floating due to surface tension. Surface tension can be described as the tendency of liquids to minimize their surface area. The paper clip will float on water. It will not float on something like gasoline or alcohol because those have weaker intermolecular forces. So what's going on here? Well, here we have an illustration, a two-dimensional illustration of what's going on inside water. And so each of these blue spheres is a water molecule. And we see that in the interior of the liquid, this molecule is interacting with 6 other molecules. There are attractive forces. These water molecules like each other. They want to be together, like friends. They're like, oh, I want to be around my friends. The molecule on the surface is interacting with things to the side and with molecules to the interior. In this illustration, only 4 friends around it. So think about going with a large group of people and sitting at picnic tables, right? Do you want to be on the corner on the end of the picnic table if these are people you really enjoy talking to? No, you'd rather be in the middle where you can talk to everybody, right? So that's what the water molecules are doing. They want to maximize the attractive forces between them, and they do that by being in the center. Nobody wants to be on the outside, and so they're going to minimize the number of water molecules that have to be on the outside. So we have this inward tension, this inward force. And so in order for something to penetrate the surface, you're going to have to disrupt those interactions and cause more molecules to be on the surface. They don't want to be on the surface. They want to be in the inside. And so they resist penetration by the paperclip or by the legs of a water skater bug or something. Interestingly, with this paperclip, if you're only able to do this if you use a very clean container and the water is very clean. If you put a little bit of soap or something on here, that paperclip will just fall, because the soap molecules mess up the attractive forces between the water molecules and break the surface tension. Any questions about surface tension? Surface tension is the reason that molecules are water drops are spherical. Any question?
Did you say water is the only one that does that, like any other liquid?
No, other liquids have surface tension, but their surface tension is not as strong as water. So you're not going to be able to float the paperclip on gasoline because the attractive forces between the gasoline molecules are weaker than those of water. But it does have surface tension. When we look at a water droplet, it has this teardrop shape, right? The teardrop shape is only because gravity is pulling down on it. If we look at water in space, here this is on the space station, big drop of water here. So the water will form a sphere, and if you bring other droplets together, you can corral them together and they'll make one giant water drop because they want to minimize the surface area. So because there's no gravity there, you can have these giant floating spheres of water. Viscosity is another property of liquids. It's the resistance of a liquid to flow. It's how thick a liquid is. So some liquids pour very easily, others are thick and pour very slowly. You can think about like water versus honey, right? Honey's a liquid, but it's really, really thick and it pours very slowly. Honey is more viscous than water. It pours more slowly. Motor oil is more viscous than gasoline. Viscosity is greater in substances that have stronger intermolecular forces. So if you think about, do I have a picture? No, not really. If you think about the particles in the liquid, in order for the liquid to pour, it has to change its shape, which means those particles need to shift their attractions. They need to break old ones and make new ones. And if the intermolecular forces are really strong, then they don't want to leave. It's like people talking to their friends, oh, we're having this great conversation. I don't want you to move down the hall. And so that you get this bottleneck in the hallway because people are talking to each other, right? So if the molecules are very attracted to each other, the liquid will pour slowly. If they're not very attracted to each other, the liquid will pour easily. They'll have low viscosity. So we see that maple syrup is another viscous liquid. It pours very slowly because the particles are very strongly attracted to each other and they can't flow past each other.